For the first time in its history, NASA brought a piece of an asteroid back to Earth. For 7 years, the OSIRIS-REx spacecraft journeyed through the inner solar system, chasing down a 4.5 billion-year-old relic named Bennu. Its goal was to grab a handful of pristine dust and rock, an ancient time capsule from the dawn of our solar system. Scientists had theories about what they'd find, the raw ingredients of planets. But when they finally got the canister open, the reality was even more intricate than they'd hoped. The dark dust from Bennu held not just the building blocks of worlds, but also abundant carbon and water locked in its minerals. It's evidence that points toward a lost, water-rich parent body, and it's helping us calibrate our understanding of where we came from. The story begins with one of the most ambitious sample return missions NASA has ever put together, OSIRIS-REx. That stands for Origins, Spectral Interpretation, Resource Identification, and Security Regolith Explorer. After launching in 2016, the spacecraft set off on its long journey to intercept Bennu. Now, this wasn't just any space rock. Bennu is a carbonaceous or carbon-rich asteroid. Think of it less as a solid rock and more as a loose collection of rubble, a rubble pile asteroid, whose materials have been wandering the solar system largely unchanged for over 4.5 billion years. By studying a pristine sample, one that hasn't been contaminated by Earth's atmosphere, scientists believed they could unlock some profound secrets. They could get a glimpse into the chemical soup that existed before our own planet was even fully formed. But the mission was a high-stakes gamble. The spacecraft had to travel millions of miles, perfectly match the orbit of an object barely a third of a mile wide, and perform a maneuver so delicate it had never been attempted before. After 2 years of travel, OSIRIS-REx finally arrived at Bennu, and that's when the first surprise was waiting for the team. Welcome to Cosmic Chronicles. We have noticed that 91% of you that watch this channel frequently do not subscribe. If you've ever enjoyed my video, please could you do me a favor and hit the subscribe button? It helps this channel more than you know, and the bigger the channel gets, the more valuable content you enjoy. From our telescopes on Earth, Bennu looked like it might have some smooth, sandy areas, perfect for a gentle sample collection. But as OSIRIS-REx got closer, the images revealed something startlingly different. The asteroid was a rugged, jagged world, covered in massive boulders. The mission team was stunned. The supposedly safe landing zones they had mapped out were gone. As one scientist put it, it was like trying to navigate a cosmic ball pit. The surface was so loose that the team realized they couldn't land in a traditional sense. They'd have to pivot to a daring touch-and-go maneuver. In October 2020, the world watched as OSIRIS-REx carefully descended toward a crater named Nightingale. It reached out its robotic arm and, for just a few heart-stopping seconds, made contact. The surface wasn't solid at all. It behaved almost like a fluid. The sampler head plunged nearly half a meter into the asteroid, far deeper than expected, and fired a blast of nitrogen gas to kick up rocks and dust. The collection was almost too successful. So much material was forced into the sampler that its lid couldn't quite close. Mission cameras spotted precious particles of Bennu's ancient dust escaping back out into space. The team had to act fast, carefully stowing the precious cargo ahead of schedule to preserve what they had fought so hard to get. With its treasure secured, OSIRIS-REx began the long journey home. On September 24, 2023, after a journey spanning billions of miles, the sample return capsule re-entered Earth's atmosphere. It streaked across the sky at over 27,000 miles per hour, enduring temperatures twice as hot as lava before its parachutes deployed for a gentle touchdown in the Utah desert. The capsule had done its job perfectly. But now, a new challenge began: getting it open. The sample was moved to a specialized clean room at NASA's Johnson Space Center, inside a glove box constantly purged with nitrogen gas to prevent any contamination. But Bennu had one last surprise in store. 2 of the 35 fasteners on the main sample container were completely stuck. Fine, dark dust from the asteroid had worked its way into the mechanism, and the team couldn't get them to budge with the tools they were approved to use inside the pristine glove box. So, for several weeks, engineers had to design and fabricate entirely new tools, custom bits made from a specific grade of surgical steel that could get the job done without contaminating the sample. Finally, they got the canister open, and the sight was breathtaking. Inside lay a treasure trove of dark, crumbly rock and dust. Once they had collected everything, including the bonus material found outside the main container, the total haul came to 121.6 grams. That's more than double the mission's 60-gram goal and the largest sample from a carbon-rich asteroid ever brought back to Earth. Now, it was time to see what secrets it held. The first major discovery was the sheer abundance of water. Not liquid water, but water locked away inside clay minerals. Initial analysis showed the sample was rich in these hydrated minerals, which confirmed what scientists had suspected from remote surveys. Bennu's parent body was once a water-rich world. And then there was the carbon. The sample was incredibly rich in carbon, the fundamental element for all known life, and contained a complex suite of organic compounds. These are the essential building blocks of life as we know it. So the big question became, what kind of organic compounds are in there? Right now, science teams around the world are on the hunt for specific prebiotic molecules. They're looking for things like amino acids, which link together to form proteins, and nucleobases, which are the informational rungs in the ladder of DNA and RNA. Finding these building blocks in such a pristine sample is a top priority, as it could give us clues about the chemical reactions that predate biology itself. Perhaps one of the most exciting finds so far has been the presence of magnesium-sodium phosphate. Phosphate is absolutely critical. It forms the structural backbone of DNA and RNA, holding the entire structure together, and it's essential for metabolism in all life on Earth. The fact that these phosphates were found in the sample and appear to be water-soluble is a huge piece of the puzzle. So, when scientists put all these pieces together, the water-bearing clays, the rich organic molecules, and the water-soluble phosphates, a stunning hypothesis begins to emerge. They theorize that Bennu's parent body wasn't just a simple rock, but may have been a small, primitive world that hosted liquid water. Some of the minerals in the sample are analogous to those formed in hydrothermal systems on Earth's own ocean floors. This doesn't mean Bennu itself was an ocean, but that it's likely a fragment of a larger, water-rich body where these key ingredients for life were mixing together in a salty chemical broth billions of years ago. This powerfully reinforces the long-standing theory that asteroids like Bennu delivered the essential ingredients for life to a young Earth. It suggests that asteroids didn't just bring water, they may have brought a pre-packaged kit of complex organic molecules and phosphates, providing the raw materials needed for life to emerge from the primordial soup of our planet. The analysis of the Bennu sample has really only just begun. For decades to come, scientists from all over the world will be studying these pristine grains, searching for more clues about the dawn of our solar system. Each tiny particle is a time capsule, and we are just starting to read the message inside. But the story of the spacecraft itself isn't over. Having successfully completed its primary mission, OSIRIS-REx was given a new name and a new destination. Now called OSIRIS-APEX for Apophis Explorer, it is on its way to a rendezvous with the asteroid Apophis. Apophis is set to make a historically close flyby of Earth in 2029, passing closer than some of our own satellites. OSIRIS-APEX will arrive shortly after this encounter to study how Earth's gravity affected the asteroid, looking for changes to its surface and spin. It's a remarkable second act for a mission that has already given us so much. The sample from Bennu is more than just a piece of an asteroid. It's a glimpse into our own cosmic origins. The discovery of abundant water-rich minerals, a complex suite of organic compounds, and evidence pointing toward an ancient, water-altered parent body is a monumental step forward in our quest to understand where we come from. As it turns out, the findings don't prove that life exists elsewhere, but they strongly suggest that the ingredients for life are not unique to Earth. They were present in the solar system from the very beginning, waiting in the darkness of space. And thanks to OSIRIS-REx, we are no longer just looking at the stars and wondering. We are holding a piece of that ancient history in our hands, and it is telling us a story more incredible than we could have ever imagined.